Somebody watching the videos, I think, are they doing okay? Are they okay? First few videos I ever made were just horrible, but I was learning. Plus I had a crappy phone back then. So, yesterday we made it through a couple of sets of data to figure out what this standard deviation number is. And what does the standard deviation try to tell us?
Vary the data.
I like it. So it gives me an idea of how far from the center. And what's the measure of center that we said sort of 1? Because there are several measures of center. What are some measures of center? Mean, median, mode, mid-range even I talked about, right? So there's several ways to gauge the center. We said the mean is the one that kind of wins out. So I can say the center, and then I want a number that tells me how far does my data get away from that center. So let me see if you guys can handle this. Standard deviation is like, how would you measure the distance between people in this room? Between two people sitting next to each other, how would you measure the distance? Would you use miles?
No.
Oh shit, no. You could, right? 0.0000. You would use maybe feet, maybe inches at most, right? Or if you like metric, you might use centimeters, and you're all like, it's America. Yeah, that's right. You know, we're the last country in the face of the earth because the other two countries that didn't use metric are in the process of moving to metric. So we will be the last country in the face of the earth that doesn't use it, and many of us are proud about that, and that's just sad to me. But oh well, too bad. That's the America we live in now. My point with this, though, is nothing. I'm sorry, it's nothing political. So standard deviation tells me is a way to kind of analyze what unit of measure should I use. So in statistics, we want to know how far apart are these two data points. And if I had data that looked like this, 1, 2, 3, 5, 7, 9, 11, would you say that 5 and 7 are very far apart? No, right? But if I had data that looked like this, 4.98, 4.982, 5.0013, 7, are 5 and 7 very far apart now?
Yes.
Do you guys, does everybody agree with that? I'm obviously trying to push you in a direction, but without me, that just makes freaking sense. So what's the difference between these two sets of data? The main difference that we've just talked about recently, how spread out they are, right? So 5 and 7 are close because the data is spread out on that same order, right? On that same level. 5 and 7 here are far apart because the data, most of the data is much closer together than those are. So standard deviation, when I calculate it, it's sort of like figuring out where the tick marks are going to go on my ruler. So if I have data that's really close together, my tick marks are going to be really close together. So that when I lay them down, I can see how far apart these are, and the measure of distance between these two will be big. Whereas for this data, maybe it'd be like that. The tick marks on my ruler, so that when I measure how far apart they are, not as far apart. All right, please. Does that make sense? A little bit. Now, right now, it might not make the most sense in the world, but I'm building up to when we eventually get to what's called z-scores.
Yes.
Some of you guys know about those? Okay. Okay. I also call standard deviations steps. So if your data is really small, you want your steps to be tiny. So, because if my data was like 0.9, 1.1, 1.3, and my steps were like this, well, I just missed that entire data set. Does that, I don't know if that makes sense. I have a very strange way of looking at things. So if I want to step around this data, I want my steps to be small. Small, so I step around the data, right? And my data was 187, 512. Then I want my steps to be freaking huge, right? All right, maybe. So standard deviation is those steps, and you can see how that kind of relates to the idea of they're the tick marks on the ruler. Okay, maybe. Now, trust me, if you don't quite get what I'm saying, this is going to be a huge part of this class that we'll continuously talk about like that. So it'll eventually, hopefully, will sink in. Yeah. Okay. So, what we ended up with yesterday is we ended up with this formula here. Have you guys remind me why we had to do certain things. Some of you, if you weren't here yesterday, it's a really good video to watch. I'm not going to redo this. Why is that square there?
Let's say for the negative.
Yeah, to kill the negatives. The damn negatives were making the average come out to be 0 always, right? And this is an average, right? Isn't an average the sum of something divided by n? That's what the average of anything is. So what this is average, it averages the distance between a data point and the mean. I really desperately want this to make sense. That should be the spread of the data. That only makes way too much sense to be real. Please let that be true. I mean, how spread out data is how far on average does it get from the middle. You can see that right there. So that's the average distance from the middle, because what are we going to do with this whole thing at the end? We're going to take a square root, so we kill those squares. I like it. All right, maybe. So quick little example. So let's say I have these data points. Let's make something that's oh, let's see, Jeff. Can you make it so it comes out nice? Maybe. Yeah, maybe. All right. Somebody help me out. How would I get the average here? Let's say this is a population. So here's my data values. Would you say the standard deviation is going to be very big? No, you can gauge that at least it's not going to be very big. In fact, that's 2 away from there. I mean, it's like, 2 or 1 or somewhere in there. So I would guess the standard deviation to be somewhere around 1 or 2. Because that's how far on average they look to get away from the middle. Does that make sense? It's nowhere near good enough to just say that, but just as an estimate before I do anything. How do I get the mean of these? Adam Romer divided by 4.
40.25.
Oh, sweet. All right, I was going for a quarter. Okay, good. So the average here. Do it again, sorry.
42.25.
Sweet. All right. Let me stop there for a second, you guys. How we doing? We haven't done anything amazing yet. And to satisfy your weird teacher that wants to see work. So I want to see this formula. And what's the when you sum these up, you got, what'd you get? 169?
69.
All right. And then you divide it by 4, and that's where that came from. I like it. So I want to see where numbers come from. And you can't just write from my calculator. I like it. So what do I want to put this next column to be?
X minus the mean.
Yeah, x minus the mean. I want to see how far away they are, and then the next thing I would do is to square. So remember, when you see a formula that's got a summation symbol in it, cover it, and I want to construct this column. So we're going to do it in steps here. Okay, so what's 41 minus 42.25? Negative 1.25, right? I like it. And then what's 41.5 minus 42.25? 0.75. 43 would be positive 0.75. And 43.5 would be 1.25. I didn't really mean to do this, and I guess it almost had to happen, but again, we got like a symmetric thing going on. It doesn't have to be that way. You can have a whole bunch of negatives as long as the positive one is big, so that it cancels out. These are always going to be close to 0. Why do I say close to 0? Because you might have rounded a bit, so it's got to be like negative 0.05 or something like that, or positive 0.07. It should be something really pretty close to 0. And if I want to use symbols for this, what symbol would I put for 0 here? What did I do to get 0? Summed up these. So I summed up those. I like it. Like it. You see, a formula tells you how to do something, but it also is another way of reminding yourself how the hell you got something. Where'd 0 come from? Oh yeah, I added these things up. Okay, cool. And now I just have to square these bad boys, right? Is this 6.25? Who is it?
1.5625.
Do it again.
1.5625.
1.5625? Oh, I put them in too far. What's this one squared? 9/16. Point, what now? 5625? And then 0.5625, and then 1.5625. I mean, are you guys still with me? Especially people that were here yesterday. It should be a really nice, quick review. And now I just add those up, because what does my formula need? It needs the sum of these things. Well, now I've got these things. Now I can add them up. And whatever you get there.
So you took the square root of the x minus mu values?
I haven't taken any square root of anything yet. I squared them, right? Squared.
Oh, you squared.
Yeah. Or, other people squared. Who is it? 4.25. Nita. All right. So what is that 4.25 in symbols? Yeah, the sum of these. That's where it came from. Don't let that be a mysterious thing. It's the sum of these things. So do you see that's beautiful? What is my formula I need on the top?
4.2.
The sum of those things, which is 4.25. So people try to stick stuff in here. Why does that make no sense? How many values are there for this? In this problem, 4. You can't put a single thing there. So you actually do it for each one, and then the accumulation you put into the formula, right? The sum of these is 4.25. And of course, n is 4. So 1.0625. 1.0625. So that is the what? The variance. I love it because I haven't taken a square root yet. This is the thing that's called the variance. Right now, this doesn't mean shit to us. It's like a middleman. It's just we haven't taken the square root yet. But the variance is remarkably important. We'll see that later in this course. Right now, I just want to get to the standard deviation, and that would be the square root of this.
1.031.
0.031.
I rounded by the numbers.
Oh, okay. All right, which goes along with what we thought maybe it looks like to be 1 or 2. So if this would have been 40, 50, 60, 70, I would have guessed maybe 15 for a standard deviation. Right, because it tells me on average how far do the data points get away from the middle. So I can kind of estimate what it's going to be. All right. So here, yes.
Are we gonna use R for something different?
Yes, R is going to mean something completely different. So you want to get used to pregnant R here, or whatever you want to call it. Right? Pregnant.
Upside down Q in the book. I didn't even know what it was in the book until.
Oh yeah, I don't know which font they use in the book at all.
It's like an upside down Q in the book.
So sometimes they're fat for me, and sometimes they're skinny for me. But that looks almost like an R. But oh well. That's how you make that symbol, right? Start at the stomach, go around to the head, or however you look at that. The biology of these things, I don't know. All right. So, let me hand this out. On one side is a completely worked out problem. And the questions I ask you on the sheet are the kind of questions I like to ask you on a test. Hint, hint. All right. On the back is a problem I want you to work out yourselves. You can work with other people. I forgot my bag of calculators, my what I call calculator cooler. I left it back in my office. So if you don't have one, you might want to team up with somebody that has one. Oh, let me show you this. Here. this was a very small set of data, but let me show you how you can make this list in your calculator. I don't think we've done that yet. Okay.
And it didn't work.
Aw, shit.
I tried.
Well, there's no try. Well, let's see what happens. Sorry. I just... Oh, well. Anybody ever heard of Bad Lip Reading, the YouTube channel? Have you seen...
They're so funny.
Stop it now. You can tell I watched it way too often. Some of you guys are like, what the hell is he talking about? So let me show you this because it's going to help you out. So when you have a longer list of data, this is not Math 88. I'm not testing your ability to subtract. I'd rather just let the calculator unleash itself on that and then copy it down. That'd be awesome. Because we are well past that stage. We know subtraction, hopefully. There it is. Okay. Let me show you. This is going to be something we use multiple times during the semester, obviously, as not just putting data into a list. That's what we did last time. But then doing other things with the other list to analyze that. So this would be like list 1. This will be list 2. This will be list 3. It's crazy. I like it. Oh, there. Somebody play with those lights back there so you get a good. The one that's in whiteboard for sure. And then. Yeah. There we go. Oh, that's fine. We can see plenty good. Go ahead, turn them all on. Everybody good? We got nice sunlight coming in. Oh, the computer is almost. There it is. Turn the volume all the way down finally, so if you like that little twang thing, it's too bad you can't get it. Alright, so I'm just going to repeat. I'm going to recapture what's on the calculator, on the board there. So again, just to get in there, how do I get to my lists? Stat. And then you can go ahead and hit edit. So take a second to make sure, clear the list. Remember, don't use delete, because then the list goes away. Everybody at a point where you're able to do this. If you don't have a calculator, it's going to be on the YouTubes, right? On the internets. All right, so let's put this data in there. We got 41. Okay. So now I want to define. I want to give L2 a definition. So I don't want to. Let me say this way. Where are my x's? Which list of my x's? It's obviously where are my x's? List 1. So I want this to be list 1 minus the mean, which is 42.25. Are you with me? Mm-hmm. I like it. So then, but if I try to put it in where I currently am, it's going to try to put all that in that one spot, and obviously it's going to freak out. So if I try to say, all right, make this L1 minus 40, I forgot already, 2.25? Well, it don't matter what it's going to be, it's wrong anyway. It's going to go, what the freak? Data type, because you're trying to put an entire list into a single spot. So that's just telling you, no, dude. Go up to list 2, highlight list 2, and now you see you can define list 2 to be something. So if you ever use Excel, it's a little bit like that, except it doesn't update when you change something. Oh well. If you've never used Excel, then you don't realize what it is. So you get L1, that's X, minus 42.25. So that is X minus mu. I want to define L2 to be that, so then of course I get all those numbers from before. So you can imagine if I give you a set of 30 data points, please your dog. Let me do that.
That was so easy.
And now what do I want L3 to be? L2 squared. I want it to square L2. So go up to L3, make it equal to L2 squared, and then you get all this. Now, one more step. Because it would suck if I had to add those up by hand because I have to leave this screen to put stuff in, but I need the screen to see what the hell they are. Shit! So, here's the next level of this. First off, get out of your list. Anybody know how to get out of anywhere weird that you're in?
Yes.
Second mode, so hit quit. Right? So if your fingers hit something, you're like, what the freak is that? Hit second, quit. I like it. Stay with me now. Now if you hit the stat button, that's not going to help us. I did the wrong thing. Right above stat it says list. You see that? You can't see it up there. But so if you hit second stat, I can now go over to math and do sum. I can sum up a list. So if you go to your list category, second stat, go to list, that's where you can do stuff to your list. That kind of makes sense. You can do all this weirdness to your list. Look at that. You can find the median. Oh shit, all that kind of stuff. I like it. So if you go to number 5, which list do I want to sum up? L3. So I got to tell it, sum up L3, which is right above the 3 button. And there's the 4.25 that we got. Right? I know, man. Now, some of you know about 1var stats, which is nice. That's nice to go there and check your work. I better still see your freaking work. And your work is not, I put it into 1var stats. It's what my last teacher made it. No, screw your last teacher. Your last teacher let the calculator understand what's going on, and you were left out in the dark. Oh, fair enough. I'm not going to do that to you. If you don't appreciate that, then someday you will.